Okay, guys, if you guys can turn to page 10. Okay, page 10. So we started. We started dealing with phase shift in terms of shifting the graph left and right. On the quiz, you guys were just focusing on amplitude, stretching the graph vertically and stretching the graph either horizontally or compressing it horizontally. But now we have to further transformation is shifting the graph either left or right, depending on the C value. We did a little bit yesterday where we knew that we have to spend some time rewriting our problem if the B is not completely outside of a set of parentheses. So we want to practice a bit more with that today, and then also move into graphing. Okay, so I'm going to skip number 5 and 6. 5 and 6 is basically what you saw. These are types of questions that you saw on the quiz. The difference here, the phase shift will be 0 because we don't have any C value, nothing added or subtracted with the theta. So I'm going to skip these because you demonstrated your knowledge of that on the quiz yesterday. I want to talk about something new. So let's go to back page here. This is number 7 on page 11. Yes.
Does the amplitude, like, is it going to be negative? Like,
amplitude is always positive, but your A value can be negative.
okay.
Right. So amplitude is always just going to be that absolute value of A is that distance from the origin or from the x-axis to the height, to the max height. Okay. So we may need to spend you may need more space, especially if we want to do our table. So just to let you know, you can have this work this on a separate sheet if you like, because it did not provide a whole lot of room on this number 7 here. Okay, but let's start off with just information. Okay, let's just start off with what we were doing yesterday, which is just getting it into the correct form. Okay, so let me write this out again. So we have the A value here. That's fine. What's our B value? 2. But 2 is it's not quite in the right location. That's going to be most helpful for us. We want that 2 outside a set of parentheses or brackets. So I'm going to rewrite it. Let's get a set of brackets with the 2 and the parentheses. We want to take a 2 from both theta and that pi over 2. You're always taking the GCF out of the first term, so you're always going to start off with theta. Okay. Now, to figure out what goes in the space, we have to ask ourselves this question. 2 times what gives me pi over 2?
Pi over 4.
Pi over 4. Okay, let's try that. We know we definitely need that pi there, right? So 2 times pi over 4 gives us pi over 2. The reason why is because 2 over 4 is 1/2, and 1/2 is what we have here. Okay, so it's having to do that little bit of a puzzle to figure out what goes in this slot so that we're able to, because we want to rewrite it without changing the overall value, right? We want that 2 to be out here. The reason why is because now we can stare at this value and know exactly what the phase shift is. Before, it was kind of hidden because that 2 is not factored out. Okay, is everybody good with that step there? So if you make a mistake here, you should be able to catch yourself, because every time you put down a value, you should always double check. You should be able to distribute and get to your get to your starting value. If you distribute and you don't get there, then hopefully that will be a red flag for you, and you're going to try different numbers until you're able to get this to match. Okay. Okay, so now we're in the proper form. We're going to gather information about amplitude, period, and phase shift. Okay, so I know my A value is 5/3. I know my B value is 2. And then phase shift is going to be based off of this pi over 4. You guys know what's going to happen here? Plus means what? Left. Okay, so we're going to shift left pi over 4 units. Okay, we're going to do this last. Okay, I'm going to create a table just like how we did before, using the B value to get to the period. From the period, we get to the interval. We identify each of our subintervals. Then our final step, we're going to be dealing with that shift in our graph. Okay. Okay, so our formula for period is 2 pi over b. We know that if this is going to be a condensed period there, we have to create our new subinterval. Here's my chart.
Are we graphing it as well?
Yes, we're going to be graphing as well, right? Okay, starting, we're always going to start with 0 initially, okay? And we're going to increment by pi over 4 until we reach our period length. Oh, sorry, if you guys can do this, sorry. As you guys are writing down your initial value, try to move it as far left as possible. We're going to leave some space for some adjustments with our phase shift. So you can leave some space on the right, or on the right side of each subinterval box, so we can make some adjustments when we need it. Okay, so I'm going to keep adding 1/4, right? So 1/4, 0 plus 1/4 is 1/4, plus 1/4 is 1/2. 2/4 plus 1/4 is 3/4. And then plus 1/4 is pi. So we're going to gather our information about our initial y values, and then we're going to make the adjustment with our amplitude. Okay, so all this is review right now. Cosine starts at the max, then works its way down and back up to the max. Multiply by coefficient of 5/3. Okay, so far nothing new, right? So far nothing new. Now, are we good up to this point? Now, what's happening is that everything we see here needs to be shifted to the left by pi over 4 units. So what I'm going to do is I'm going to take each of these x values, I'm going to subtract pi over 4. That will allow all these y values to go along with my new x value. So I'm going to indicate the fact that I'm going to shift everything or subtract all these starting points by pi over 4. So I'm going to say minus pi over 4. I'm going to write it for each of these values here. And I'm going to add in or subtract these values. I'm going to put my resulting new x value above it. So 0 minus pi over 4 is what? Negative pi over 4. So that's going to be my starting point for my first order pair. Okay. All right, pi over 4 minus pi over 4, 0. 2 pi over 4 minus 1 pi over 4, 1 pi over 4. 3/4 minus 1/4, 1/2. And then pi minus 1/4 pi, 3 pi over 4. So now we're just going to be plotting our points, looking at what you have gathered from the top. This is our most updated x value, and then below is your most updated y value. So ignore the middle. You're just going to work off of the top and the bottom. So here's my graph. I'm going to plot that negative pi over 4. That's going to be 1 tick mark away on to the left of the y-axis. There's my 0, pi over 4, pi over 2, and 3 pi over 4. Okay. So at negative pi over 4, I want to graph a y value of 5/3. At 0, I want to plot a y value of 0. At pi over 4, I want to plot a y value of negative 5/3. At pi over 2, I want to plot a y value of 0. Finally, 3 pi over 4, back to the max. So what you graph, it should remind you of the cosine graph. But the only reason why it looks a little bit different is because we don't usually start with our maximum at negative pi over 4, right? We usually start at 0, but you can clearly see that impact that the shift has, right? We're taking our cosine graph that starts at 0, and we're shifting everything over to the left by pi over 4 units. Okay. Any questions there? Okay, so we're just going to be working with this new topic today. Okay, so we're just going to get in our practice. Okay, yes, question. Go ahead. So let's try number 8. Number 8 is going to feel a little easier. Why is that? Yeah, b is just 1, which means that we don't have to go through that step of factoring it out. And that also means that your parent period is not going to change, your interval is not going to change, so you can use your original interval and the original period of your problem. The only thing you have to adjust at the very end is you want to be able to make your appropriate shift. But we'll save that for the end, right? We'll save that for the end. Okay, so find your A value. Your B value is 1, so that means all your original subinterval will just be what you would expect from a normal graph, from a sine graph. Once you have created your initial chart, then you can make your final adjustments with however far you want to shift either left or right. Make sure that we're on the right track here. What direction is this graph going to shift? Right. To the right. We're going to do plus pi, right? Plus pi for every one of your original subinterval x values.
With the period, you just do 2 pi.
2 pi, that's right. Because your b value is 1, so nothing has changed. Shift to the left, right? Shift it this way. So normally your cosine graph would start here, the max, but imagine this was the cosine graph, it would shift it to the left. So instead of starting at 0 power 4, now starting at a power 4.
Is that right?
That's the initial one, right?
But like it's
And then you're going to go through the add pi,
including 0.
including 0, right? Everything is going to get shifted. So my original x value intervals are at 0, pi over 2, pi, 3 pi over 2, and 2 pi. We realize that the minus pi is going to shift the graph to the right, which means we're going to be adding, we're going to be moving each of these x values to the right by pi units. So 0 plus pi is pi, 1/2 pi plus pi is 3/2 pi, pi plus pi is 2 pi, 3/2 plus 1 is same thing as 3/2 plus 2/2, which is 5/2, and then 2 plus 1 is 3. So now, instead of starting at 0, now you're going to be plotting your points at pi. That's going to be the beginning of your sine graph cycle. So order pair, pi, comma 0. Then we go to our max at 3 pi over 2, back to 0 at 2 pi, minimum at 5 pi over 2, and then back to 0. Yes. Sorry? So originally, if there was not this minus pi here, then your graph would look like this. So imagine this was the original graph, and then that minus pi is just going to shift everything over to this graph that we have. Okay, any questions with 8? Okay.
A lot of work.
Hmm?
A lot of work.
Yeah, but we're just kind of building, we're just taking it one step at a time, right? We're just taking what we did with amplitude and b value, and we're learning another way to change up the graph. Okay. Number 9. So here's number 9. Is everybody done? Everybody done with 8? Okay. Okay. Y is equal to okay, so the first thing we need to do is we need to get that bracket parentheses to be in a better form, because this pi over 8 is not showing us the true phase shift. Okay, what's the b value? 1/4. Okay, so bracket 1/4 theta minus parentheses bracket. Okay, so we got to play around with this here. 1/4 times what will give me pi over 8? I know I need the pi, so I can have that in place. What else do I need? 2. All right, let's try that. Okay. What's 1 times pi? Pi. What's 4 times 2? 8. Okay. So just understand that, if you somehow made a mistake, you should always be able to catch yourself, because if you distribute through and if you aren't able to get back to your starting point, then keep trying a different number, right? But hopefully after a couple of tries, you'll be able to confirm the correct value that's going to sit here. Okay, so it shouldn't be a guessing game. We should be able to always confirm that we're on the right track. Okay. All right, so start from here. Your A value, your B value, you know that there's going to be a change in your period and your interval. And at the very end, you can make that adjustment with that pi over 2.
So. You do 2 pi, 4 pi, 6.
That's right. That's your original interval. But once you fill out everything, then you can make that final adjustment with what to do with that pi over 2. Okay, minus pi over 2 means we're going to shift to the right, so plus. Okay, 0 plus 1/2, 4 halves plus 1/2, 8 fourths plus 1/2. Sorry, 8 halves plus 1/2. So I'm finding all the common denominators over 2. So I'm making 2 4 over 2. This is 8 over 2 plus 1 over 2. 12 over 2 plus 1 over 2. 16 over 2 plus 1 over 2. Okay, any questions with that? So now you're the line that I have in red, those are your new x values, and then your new y values are at the very bottom. So you're just creating a bunch of ordered pairs, connecting the dots, and it should look like a shifted version of the cosine graph. The reason why we're adding this pi over 2 is because we have to physically pick up all the points and shift it to the right pi over 2. Okay, any questions? Okay, to get done with 9, let's try number 10. We have to make an adjustment like how we did with number 9. Got to factor that b out and then figure out what to do with that c value. Okay, any questions with number 9? So if you look at your graph, it should resemble the cosine graph. It's just that instead of the max starting at 0, you see that the max height is starting at pi over 2, just like what we wanted, right? We wanted our cosine graph to shift its starting point and the rest of its graph over to the right by pi over 2. Okay, try number 10. So what's your b value? So we're going to do this. Trying to figure out 1/2 times what will give me 3 pi over 2.
No. Yeah.
Times 2. Let's try it.
Wait, that could be wrong.
Because what if the original one looked like this, right? The original one is 1/2 beta plus. Right? You said
Yeah,
you said
times
So 1/2 times 2 is
3 pi.
1/2 times 2 is just 2 over 2, right? So that's not going to match. What else? Times 4. Let's try it. 1/2 times 4 will give me 2. That's not the same.
Times 5.
That's 5. 1/2 times 5 will give me 5/2.
I don't know.
Yeah, okay. Well, we need a pioneer, right?
1/2 plus 1/2 plus 1/2. So times 3.
Right? Yeah.
And then you do the same thing here. You multiply this by
Does that work?
Over 2.
1/2. Well, if I do it over 2, then it becomes 3 pi over 4. So I think just 3 pi will do it.
Just 3 pi.
Does that make sense?
Yeah.
Because 1/2 times 3 pi is equal to 3 pi.
Don't want to see it.
Go on your paper.
I was saying just be 3.
So it's just take 3 pi.
You don't want to have paper, don't you? I have so cramped as it is.
I'm literally just writing so small.
Okay, we have to go through that effort of factoring out that 1/2. Once we factor that 1/2 out, we have to figure out 1/2 times what will give me 3 pi over 2. So 1/2 times 3 pi will give me 3 pi over 2. And now we know, now that number is going to be a true reflection of our phase shift. So your A value, your B value, find your new period, find your new interval.
Did something wrong. I shifted the wrong way. I know which way to shift it. I just was thinking about 9 and I shifted the wrong way.
Wait for number 10?
Yeah,
that's right.
I did it right. I just shifted the wrong way.
That's good. That means you're almost there. But I think this is the hard part, right?
I just didn't look at it.
Trying to get that. Trying to make the adjustment so that this is the right value.
But is this, if this was shifted right, is this correct? If this was a negative.
Yeah.
Alright, well, my process for negative.
This isn't gonna have
Exactly, right. It's going to be weird, right? All the sub-intervals are going to be numeric values, all the signs are.
Is that it?
I was-
Like what? I don't
Yeah. Well, build all your initial values first, right?
Right, but if it's over 3, and it starts at 1/2, how do you get to the 3?
Your interval should be 1/4 times p, so it should be 1/6.
Yeah.
Because your period is
Oh.
your period is 2/3, right?
Yes.
So I need to find my interval.
2/3 times. Yeah.
I don't get it.
Yeah, I got it. 1/6.
1/6. 1/6.
Ellie,
2/12.
2/12.
Oh my God. Oh boy.
And then once you have all your subintervals, then you can subtract. You can subtract 1/3.
I thought 2/12 was 1/2.
Oh my God, it's hard, right?
Guys, 11 and 12 is part of your homework. I want to make sure I get through 13 and 14 because we need to be able to look at a graph and be able to identify sine and cosine functions from it. So, because any sine graph is just a shifted cosine graph and vice versa, okay? So if you guys can turn, just hold off on 11 and 12 for now, and let's go to number 13. Okay, so number 13. Okay, so 13.
I'm literally in a
Okay. So number 13, look at this graph here. Normally, we think of cosine graph as starting at the max, but we can think of this as a cosine graph that's reflected. Okay. Another thing I want to point out to you is, what is the cycle? What does the period look like for this graph here? How long before it completes its cycle? Pi, right? You see how this is half, that's half a pi. The other side is half a pi. We add half plus 1/2, we get pi. So we know that our period is going to be pi. Right. So next up, we have to figure out, let's go after cosine first. Okay, I think it's a little bit easier to go after cosine. Our period is going to be 2 pi over b. So if I cross multiply, so b equals 2. Okay. Now, just by looking at this graph here, what do you think the a value is if we're targeting cosine? Good. It's -4, right? Because usually we expect cosine to start at the peak. Now it's going to start at the minimum. But we know that distance is going to be 4, so our a is -4. Okay, so here's my cosine graph, or cosine function. Y equals -4. There's no shift, no phase shift. So cosine, and then we have our b value. So it's a little bit easier with the cosine equation because it's already kind of in a cosine form. Okay, what's more challenging is trying to create a sine formula equation for this graph. But any questions up to this point? Does everybody see how this is basically a cosine graph here. Now, how do we do this with a sine graph? You see how this resembles the cosine? Can we imagine kind of shifting the graph and making it into a sine graph? So here is maybe a sine graph that would be a shifted version of this graph that I'm trying to figure out. I'm just going to do a small portion of it just so that we can see. So do you see how this is basically the sine graph that I have in red? So here's our goal here. We're going to create a formula for this sine curve, and then at the very end, we'll do the appropriate phase shift so that this will turn into the graph that we want. Does that make sense? So let's just focus on creating a formula for the sine curve. And then at the very end, we'll deal with the phase shift, which will allow it to push to the right. Okay, so this is basically our sine graph. What's the a value for the sine graph? Positive or -4? Positive, right? This basically looks like the original sine graph, right? So there's no reflection that we have to adjust. So I think we just say y is equal to 4 sine. Is the period going to be any different than the cosine? Same, right? So the b is still going to be 2. Okay, so we can fill that part in. Bracket 2 parentheses theta. So this, right now, what we have is the graph in red. Okay, we've created the graph in red, but that's not our ultimate goal, right? Our ultimate goal is we want to create this graph, this original graph in black. So what can I do with this graph in red to turn it into what I want? I need to shift it to the right. So minus pi over 4, right? Okay, so minus. Everything is opposites if we're pulling something from the equation or out of it for phase shift. So again, this is the formula for the sine curve in red, but that's not what we want. We want it to be shifting to the right. So that's why we include that minus pi over 4. Does that make sense? Okay. Let's do one more, and then we'll be done. Okay, so number 14. Let's start with the easier one. This looks more like the cosine or sine graph. Looks like the sine graph, right? So let's do the easier one first. Let's go after the sine graph. So what's the a value for this sine graph? 0.5, right? It's not reflected, so it's moving in the way that we expect from a sine graph. What's the period? How long does it take to complete its cycle? 6 pi, right? So 1.5 plus 1.5 becomes 3, plus 1.5 is 4.5. So good, 6 pi. Okay, we have to work backwards to figure out what the b value is. So here's our formula. Period over 1 is equal to 2 pi over b. Okay, cross multiply. Oh, so I knew that my cycle starts here and ends at that fourth tick mark.
Oh.
And so I see enough context clues for me to add 1.5 pi to get to there. Okay, good so far? All right, so here's our sine graph, our sine function. Y is equal to, you set 0.5, there's no negative, and there's no phase shift because this is already in the shape of a parent sine graph. So sine parentheses 1/3 theta. Okay, are we okay with that? Okay, next up, we want to create a cosine function. So you see how if I just move it slightly, I can make it into a cosine function. So I'm going to graph a cosine function I'm going to create, and then I'll worry about moving it. So let's create the graph in red, and then at the very final step, we can worry about shifting it to turn into the graph that we want. Okay, so y equals, what's my a value for this cosine graph? Positive or negative 0.5? Positive, right? It's starting at the max that we would expect from a normal cosine graph. Okay, so 0.5. Is our b value going to change? Same, right? It's the same cycle. We're just shifting it. So bracket 1/3 parentheses theta. Okay, so right now we have the graph in red. Okay, are we good with that? This is our graph in red. But that's not our goal, right? We want to shift it a certain distance in the correct direction. So what do we need to do with that graph in red? Plus or minus? Minus how much? 3 pi over 2, right? We want it to shift one tick mark over. And each tick mark is distance of 3 pi over 2. Okay, any questions? Yeah.
Yeah, what did you use to graph the
I knew that I wanted to, it said to create a cosine function, so I know that I needed to start at something that resembled a cosine function. So if I can imagine this graph as just shifting slightly, I can see that if I just take this cosine graph, I can move it left or right to get it to look like this. So that's why I created a cosine graph that was next to this one in the hopes that I can move it to turn into this graph in black. Does that make sense? So it's asking us to do a cosine graph, so I'm purposely creating a cosine graph next to it in hopes of me being able to get it to the correct place with the shift. Okay, guys, your homework is going to be just number 11 and 12. I'll send out a reminder this afternoon. I'll also send out a key so you guys can check your answer. Okay, so your homework, just number 11 and 12 on page 11. Yeah. Exactly. That's kind of strange, right? Everything goes away.
Oh. Page 11, number 11. Oh wait, so 11. Page 11, numbers 11 through 12. That's only 2 problems. That's not a lot. It's now for school. Stop it.
I thought you were eating yesterday. Isn't it every other day? Oh, yeah.
Oh, okay, I'll just go with the period. This one, I see that it starts here and it ends here. Right? Yeah, go ahead. Because isn't this a full sine cycle? So I know that it starts here and it ends 4 tick marks later. So I got to figure that value if I just add 3 pi over 2. This one's a little bit harder because it's hard to see. So I like to do this. I like to look at from here to here because this looks like a full sine.
Yeah.
Sorry, cosine cycle. But you see how this is pi? This is a 1/2 pi. That's also 1/2 pi. So 1/2 pi plus 1/2 pi is plus 1 pi. So I know that that distance is pi, which allows me to then help me find my b value.
Oh,
Like, is it from here to here is 6, right?
Yeah,
Like,
yeah.
from the period for this one, 3, 5, 4.
Yeah, I think the difficulty of looking at it from here is that it doesn't quite finish the cycle. If we start here, if we follow the graph, it'll eventually end at
So
6
is it
pi.
always going to be the very last one?
Well, another way to look at it is you know what a cosine graph looks like.
Yeah.
It starts at a peak and ends at the peak. So you can also look at it from this perspective and say, well, what's the distance from here to here? That's 1/2 pi, that's 1/2 pi, so that's going to be a 1 pi. Right.